In this lecture, we are going to look at transposition ciphers. These are also symmetric encryption techniques. So we have one key that is used for both encryption and decryption. However, here the elements in the plaintext are rearranged or permuted to hide the message and generate the ciphertext. We will go through two classical transposition ciphers, namely Railfence and Columnar transposition cipher. Both of them were originally proposed to work with letters, but can be used for numbers and other characters as well. So Railfence cipher gets its name from the way it is encoded using a railfence. In a railfence, we have these vertical posts, as you can see here, and then we have horizontal rails to support them. This sort of makes a grid, which is what is used in this cipher. It is also known as a zigzag cipher from the way letters are written, and we will see that shortly. Here the key represents the number of rails on this imaginary fence, so basically the number of rows here. So for instance, in this grid we have 3 rails since we have 3 rows. So how do you encrypt using a Railfence cipher? Let's say you have plain text equal to this is a secret, and the key is 3, which means we have 3 rows or 3 rails. Now before encryption we usually remove spaces, but you can also replace the spaces with X's, as you can see here. So plain text will become something like either this or this. Now we will start filling this grid right here in a zigzag manner. So we will write the plain text downwards and diagonally on successive rails of this imaginary railfence, and then moving up when we get to the bottom. So as you can see here, so the arrows here from left to right show you the direction in which to write the letters. Right, so you can see here we are writing in a zigzag manner. And so the message is then read off in rows to generate the ciphertext. So this is the ciphertext. How is it generated? We will first read the letters in the first row, which is T-I-E-T. Then we will read the letters in the second row, which are H, S, 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 C, E, and then the letters in the third row, which are I, A, R. So again, to summarize the encryption process, the plain text is written downwards and diagonal on successive rails of this imaginary railfence, and then moving up when we get to the bottom of the grid. The message is then read off row by row to generate the ciphertext. Okay, so pause here and complete this exercise. So assuming you have completed the exercise, the answer is MEMATRHTGPRYETEFEDEOAAT. For Railfence cipher decryption, we need to first find out the number of columns or the fences in the grid. This is equal to the length of the ciphertext, or the number of letters in the ciphertext. Similarly, the number of rows or rails is equal to the key. Similar to how it was in the encryption process, because again this is symmetric key encryption scheme. And then we start writing the ciphertext letters in the grid by filling it row by row, as opposed to in the encryption process where we were writing it in a zigzag manner. However, here also we will still ensure that we maintain the zigzag pattern. And then once we have written all the ciphertext down, we will read off the plain text in a zigzag manner. So let's use the ciphertext from the previous example, which is this one. And so we will use the same key, which is 3. Right, so I have plotted these dots here on this grid to show you the zigzag pattern that you're supposed to maintain as you are writing down the ciphertext letters, right? So we will first fill up the first row, then second row, and then third row, but we will only write the letters in these dots, right? So first we will write TIET, and then we are going to write HSSSCE, and then finally we are going to write IAR, and you can notice here that we are maintaining this zigzag pattern right here. And so then we will read off the plain text in a zigzag manner. And so we get back our plain text. Right, so we are going to read it off in the way we were actually writing plain text during encryption. So for example, like this. All right, pause here and complete this exercise. So assuming you have completed the exercise, the answer is transposition. The next transposition cipher is Columnar transposition cipher. In this cipher, the message is written out in rows of a fixed length and then read out again column by column. And the columns are chosen in some scrambled order. Both the width of the rows or the length of the rows and the permutation of the columns are defined by the key. Let's say our plain text is the sentence, "The quick brown fox jumped over the lazy dog," and the key is Cornell. So we will write the plain text in rows of 7 letters each because there are 7 letters in our key. To read off the ciphertext, we need a column permutation or order. So we will define the column reading order based on the alphabetical order of the key letters here, right? So this is our key, and we will see that which of these letters come first in the English alphabet, which of these come later in the English alphabet, and according to that, we will define the order from 1 onwards, all the way to 7. So C appears first alphabetically among the remaining letters of this word. So we give it 1. So we will read out the first column first. Then E comes second alphabetically. So we will assign 2 at this position where E is, which means that we will read out this 5th column next, and so on. And you can see here R appears alphabetically at the very end in this word. So we assign 7 at the location where R is, which means that this column will be read at the very end. And we also see that there are 2 L's which appear in this word. And so because they have the same position in the English alphabet, we are just going to assign them numbers from left to right. Right, so we will read this column out first and then this column. So we start filling our plain text row by row here, right? So you can see here the first row, second row, third row, 4th, 5th, and 6th, right? And in the very last row, we have put fillers because we want to keep all the rows of the same width. Now we have 7 columns here, as you can see. Each column has a different color to make it easy to differentiate them as we are reading them out to generate our ciphertext. So we will read the letters in the black column first because it has number 1 written above it. Then we are going to read the blue column because we see 2 over here. And then we're going to read the purple column because we see 3 here. Then we're going to read the green column because we see 4 here. Then we will read the orange column because we see 5 here. And then the red column, and lastly the pink column. Right, so we have this as our ciphertext. All right, pause here and complete this exercise. Okay, so assuming you have completed the exercise, the answer is EVLNX, ACDTX, ESEAX, ROFOX, DEECX, WIREE. In columnar transposition cipher decryption, you first have to find out how long the column height is. We already know the row width, which is basically equal to the key size. So to find out the column height, we divide the ciphertext into chunks, whose size is equal to the length of the ciphertext divided by the key length, right? So these chunks are basically the columns, the column size. Once we have the ciphertext chunks or the columns, then we write them out. But which order we write them in is defined by the alphabetical order of the key letters, just like in the encryption. And finally, we are going to read off the plaintext row by row. So we have an example of ciphertext here. The key is again Cornell. So we have this ciphertext block, and we need to find out how to divide it into columns. We don't really know the column height at this point. So we are going to basically find out the letters in the number of letters in the ciphertext, which is 42, and then we'll divide that by the length of the key, which is 7. So we get 6. Basically, this means that we are going to divide the ciphertext into chunks of 6 letters, which means that we have columns, each having 6 letters. Now we have to write these chunks as columns in the appropriate location. You can see the alphabetical order of the key letters here. This is similar to how we had this in encryption. Now we are going to write the first chunk, which is TKODEG, corresponding to the key letter which is assigned order 1 alphabetically. Right, so we are going to take this chunk and put it here. Then we write the second chunk, which is UWMRYX, in the location of the key letter, which is assigned order 2. So you can see that E is assigned order 2 because alphabetically it comes after C. So we are going to write the second chunk below it, and so on. Finally, we will read off the letters row by row to get back our plain text.